Scientific notation. Well, what exactly is scientific notation? Scientific notation is just a much easier way to write really big or really small numbers. For example, in December 2010, scientists reported that there were 300 sextillion stars adrift in the sky. Here's what 300 sextillion looks like. It's a pretty big number. It's a 3 followed by 23 zeros. Well, if you had to write this number numerically all day long, it would be pretty exhausting. A much easier way to write that number is to use scientific notation, and this is what that looks like. So in this video, we're going to explore how you write really large numbers using scientific notation. So scientific notation is written as the product of a number that is equal to or greater than 1, it has to be less than 10, and a power of 10. So it's the product of a number that is equal to or greater than 1, less than 10, and the power of 10. So if you wanted to show the population of the United States, which is 300 million, this is how you would do it using scientific notation. Well, let's look at what we already know before we delve into scientific notation. These are all powers of 10. So they're all exponents that have a base, which is 10, and an exponent. And the exponent tells you how many zeros. So here we have a base of 10. You would have a 1 and 2 zeros. A common mistake that kids will make is they'll have, for 10 to the second power, they'll take 10 and then add 2 zeros. Well, that's incorrect. It's 10 to the third power would be a 1 and 3 zeros. 10 to the fourth power is a 1 and 4 zeros. So let's just see if you remember this. So this would have how many zeros then? It would be a 1 and 2 zeros. This would be a 1 and 3 zeros. This would be a 1 and 4 zeros. And this is a pretty big number. This would be a 1 and 17 zeros. And in case you were wondering what that number is, that is 100 quadrillion. Okay, so if you remember, when you're multiplying or dividing by powers of 10, the zeros tell you how far to move the decimal point. For example, when you're multiplying times 1,000, there are 3 zeros, which means you would move the decimal point 3 spots. If you were multiplying 6 thousandths times 10,000, there are 4 zeros here, so you would move the decimal 4 to the right. That would be 60. If you were multiplying 48 times 100, you would move it 2 spots to the right. That'd be 4,800. And if you were multiplying 47 and 900ths times 10, there's 1 0. You would move the decimal 1 to the right. Well, scientific notation, 4.5 times 10 to the fourth power is exactly the same as 4.5 times 10,000, because 10 to the fourth power is a 1 with 4 0. These are exactly the same thing. So when you're doing scientific notation, if you wanted to write this in standard form, the exponent tells you how many spots to move the decimal point. So you would move the decimal 4 to the right. And that would be 15,000. You would move the decimal point 3 to the right here. So if you wanted to change this back from scientific notation into standard form, it'd be 2,730. All right, let's just try a few of these. So here's some scientific notation, and we want to convert these numbers back into standard form. Well, it's 10 to the third power, so we would move the decimal 3 spots. That would be 5,900. If you wanted to convert this back into standard form, we're going to move the decimal 4 to the right. We would need to add a couple of zeros. That would be 83,300. We would move the decimal 5 to the right. 1, 2, 3, 4, 5. Add our zeros. Put in our comma. It would be 110,000. We would move the decimal here 6 spots. 1, 2, 3, 4, 5, 6. Get in our commas. That would be 7,062,000. If you wanted to convert this into standard form, it's pretty easy. That'd be 690. And this one, this is a pretty big number. We would actually move the decimal 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Get our zeros in here. Put in our commas. 1, 2, 3, comma, 1, 2, 3, comma. So that would be 9,150,000,000. So it's easy. So to convert from scientific notation back into standard form, the exponent tells you how many spots to move that decimal to the right. What about negative exponents in scientific notation? Well, here we have a negative exponent. With a positive exponent, we move the decimal to the right. So what do you think would happen if we had a negative exponent? That's right, we would actually move the decimal 4 spots to the left. And in this example, we would move the decimal 3 spots to the left. So 2.73 times 10 to the negative third, that would be our end result. Okay, so how do you write large numbers using scientific notation? Well, remember, the first number needs to be between 1 and 10. It can be equal to 1, but it has to be less than 10. So if you wanted to write 2,300,000 using scientific notation, that first number needs to be between 1 and 10, so it would be 2.3. And how many spots did I move that decimal? I moved it 6 spots. So that would be 2.3 times 10 to the 6th power. How would I write 140,000? Well, the first number needs to be between 1 and 10, so it would be 1.4. How many spots did I move that decimal? I moved it 5 spots. If you wanted to write 3 billion using scientific notation, you would need to move that decimal. So the first number would be between 1 and 10. And how many spots did I move it? I moved it 9 spots. Let's do one more. So this is 68 trillion. You'd need to move that decimal 10 spots. That first number's got to be between 1 and 10, and I moved it 13 places. It'd be 10 to the 13th power. And we'll do one more here. So this is 352 billion. You would need to move the decimal until that number is between 1 and 10, so 3.52, and I moved it a total of 11 spots. So it would be 3.52 times 10 to the 11th power. Let's try a few of these. So this would be 3.35 times 10 to the 6th, because I moved it 6 spots. First number needs to be between 1 and 10, so it would be 2.23 times 10 to the 8th power. This would be 1.6 times 10 to the 6th power. Move that decimal so that I have a number between 1 and 10, and I needed to move it 4 spots. This would be 6.8 times 10, and I moved it 6 spots, 6 places. And then this one would just be 4 or 4.0, either one, times 10 to the 5th power. Okay, let's just wrap this up and look at these 5 examples. Some of them are right, some are not. Let's see if these are correct. So here's our standard form. And this person is saying that would be 5 times 10 to the third power. Well, the first number's between 1 and 10. That's good. Would you move the decimal 3 spots? Yes, you would. So that one's correct. This one, the first number's between 1 and 10, so that's good. Are you moving the decimal 4 spots? Let's see. 1, 2, 3, 4. Nope, you're moving it 5. That should have been to the 5th power. This one, whoop, first number is not between 1 and 10, so that's incorrect. We know this is incorrect as well, because that first number needs to be equal to 1 or greater than 1, but less than 10. This is way more than 10, so that's incorrect. Well, this one looks like it might be right. The first number is between 1 and 10. And did we move the decimal 6 spots? Well, actually, that first number is incorrect. Look, 3, 4, 5. It should be 6.03 times 10 to the 5th power. So there's a couple of things wrong with this one. So that's all there is to it. And that's how you do scientific notation.